Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're going to be going over section 8.2. Just remember, I'm going to assume that you kind of know section 8 well. But yeah, let's just get started. So 8.2, let's talk about the following here. So section 8.2, you are being asked to solve what's called 3 by 3 systems of equations. And what that is the following, is that you have three equations with three variables. Okay, so what I'm going to show you is the following here. Now the book and the PowerPoints, they may have you do two different ways. I'm just going to show you one way of how to solve a 3 by 3 equation just because I think it's a lot easier than the other one. If you want to use by substitution, by all means go for it, but I'm not a huge fan of it um, for just kind of um, just I feel like the steps can be a lot more complicated. And when you're solving a 3 by 3, I don't really care which way you use as long as you show your work. Okay, so I'm going to do what's called solving by elimination. Okay, and so the idea is um, what we're going to do is we're going to have we're going to use two equations and we're going to eliminate one variable. Okay, so for example, I'm going to use this top one. I'll use these top two, right? So I have 2x plus y plus z is equal to 4, and then negative 3x plus 2y minus 2z is equal to negative 10. Okay, so I'm going to eliminate y. So I'm going to multiply the top equation by negative 2. So I have negative 4x minus 2y minus 2z is equal to negative 8. Okay, so this is what we're going to do. Let's combine them. Right, and what should happen is my y's cancel out. So I have negative 7x minus 4z is equal to negative 18. So that'll be my first equation. I'm eliminating y. Okay. Okay. So the next type of equation is the following. So I'm going to use a different color. So I'm going to pick two other equations. So in this case, I'll pick the second and third. And I'm going to also eliminate y as well. So when you do each pair, you want to make sure you eliminate the same letter. So here I have negative 3x plus 2y minus 2z is equal to negative 10. And I have x minus 2y plus 3z is equal to 7. And thankfully for us, as you can see, we don't need to multiply either row by a particular number. So I just combine. So I have negative 2x, and I have plus z is equal to negative 3. Or the following here. Okay? So what we're going to do is we're going to do another elimination. So notice the situation at hand, right? So we have three equations with three variables. Notice when I eliminate the same variable twice, I'm now down to two equations with two variables. And we know how to do that, right? It's a 2 by 2 equation. So I'll solve by comparing these two. And I'm going to multiply the bottom row by 4, right, to get rid of z. So this is the following. Negative 8x plus 4z is equal to negative 12. Negative 7x minus 4z is equal to negative 18. So we're going to combine. So I have negative 15x equals negative 30. I'll divide both sides by negative 15. And I have x is equal to 2. Okay. So I got one of my variables. And what I'm going to do next is I'm going to plug them back in. Okay, so it's very similar to solving a 2 by 2, right? You take your x value, right? Once you find one of your letters, plug it in to find the other one. We're going to do the same thing. Now, if you notice, for the following, notice I cannot plug my 2 back into my original equation, right? Because notice I have y and z, so that's not helpful. However, I can plug this back into one of my 2 by 2s, okay? And as you can see, you need to be very careful because it's really easy to mess up, okay? So I have negative 2 times 2 plus z is equal to negative 3. I have negative 4 plus z is equal to negative 3. I'll add 4 to both sides. And I have z is equal to 1. So now that I have x equals 2, z is equal to 1, I'm going to plug it back into one of my originals. Yeah, let's do the very top one. So I have 2x plus y plus z is equal to 4. And this is 2 times 2 plus y plus 1 is equal to 4. And I have 5 plus y is equal to 4. And I have y is equal to negative 1. So I have 2 comma negative 1 comma 1. That's what you'll write. You'll write it as a coordinate, okay? So remember, a 3 by 3 is if you graph them, okay, and you should have this packet with you. If you graph them, you're actually graphing planes, or essentially rectangles, okay? And let me show this picture up to Hugh. So the idea is if I have these squares, right, or these kind of, essentially think of it as like papers, right? So my papers can intersect at a particular point, they could intersect at a particular line, or they could not intersect at all. And one thing too is number C is even though these three intersect, they don't all intersect. You see that? So if you know, it's only like either the blue and purple intersect or the blue and orange intersect, but they all don't intersect at the same point. Okay. So, but generally they intersect at one point or a coordinate, and it's actually 3D. If you ever take calculus later on, you'll do a lot of 3D objects. So if I have 3 coordinates, we're actually talking about a 3D plane, okay? So x goes left and right, y goes up and down, and then z, which is new, it goes in and out. Okay, so the z is actually your is a 3D coordinate for the following. Okay, and so we can double check, right? Because if I plug in 2, negative 1, 1, let's see if it works. So top one works. Negative 3 times 2 is negative 6. And then 2 times negative 1 is negative 2. So that gives me negative 8. And then negative 2 times 1 is negative 2, that's negative 10. So that works out. In the third equation, I have 2 for x. And then negative 2 times negative 1 is 2, so 2 plus 2 is 4. 3 times 1 is 3. 3 plus 4 is 7, so that works out. Okay. Sorry I'm writing it all, sorry I'm like verbalizing, but idea is, remember, if you plug it in all 3, it should match out, and that's what you get right there. Okay. Okay, so let's do another example here. Okay, so let me do another example like this one here. Okay. Yeah, so I'm going to jump over to number 6 for the following here. So number 6 is a little bit interesting because if you notice, you have missing letters, and it does happen. Okay, so how do we deal with like a missing letter? Okay, and it's actually not that difficult. So it's actually, in fact, it's actually a little bit easier than the one we've done before. So if you notice I'm missing a Z, so here's what I'm gonna do. I'm going to actually do equation 2 and equation 3, and I'm going to eliminate z. Okay? The reason why I'm doing this is because watch what happens once I eliminate z, okay? So actually just combine. I don't need to multiply either row by anything. So I have 4x plus 3y is equal to 4, okay? Now, some of you are like, how am I going to pick another 2? Well, the nice thing is, if you notice, my top equation, which I haven't used that, already does not have a z. So all I do is just bring it down. And then I can go from there. I'm going to multiply by -2 because I want to eliminate x. So this becomes 4x plus 3y equals 4. Sorry, I'm just kind of copying this down. And this becomes -4x minus 2y is equal to -4. So I have y is equal to 0. Okay. So now I'm going to plug into my 2D equation, one with 2x2's. So this is going to be 4x plus 3 times 0 is equal to 4. 4x is equal to 4. Divide both sides by 4. And remember, I plugged these two into a 3 by 3 equation. So this is going to be, it doesn't matter which one. Actually, it does, sorry. I don't want to plug into the first one because I don't have a z, so I need to solve for my z. I'll do that x plus y minus z is equal to 4. So this is going to be 1 plus 0 minus z is equal to 4. So that means negative z is equal to 3. Divide both sides by -1. I have z is equal to -3. So I have 1, 0, -3 as my final answer. Okay. Let's see. Yep. So I plugged them all in, and they all work out. Okay. For the following here. Okay. Let's do one more example. I'm going to do, sorry, I'm going to scroll all the way back to number 2. Or actually, not do number 2. Let's do number 3. So some of you guys are probably wondering, how do I know which letter to eliminate first? Technically, it doesn't matter. Whichever one you do first, when you eliminate second or you eliminate third, it doesn't really matter order. However, yeah, so order, like whichever one you eliminate, you should technically get the same answer. The only thing that you have to be mindful about is just kind of the amount of work, okay? So for example, if I look at number 3, I actually don't want to use y because I have to do a lot of multiplication. But if I look at something like z, if you notice, it's actually easy to combine. And sometimes I don't even need to multiply by anything, get rid of z. Okay, so for example, I'm going to do the first two. And if you notice, if I want to eliminate z, right, all I do is just combine my two rows. So I have x plus y minus z is equal to 6. And then 3x minus 2y plus z is equal to -5. I'm going to combine. My z's are away, so I have -y, and I have 4x is equal to 1. Okay? So I'm going to pick my other two equations. I'll pick, yeah, I'll pick the other two. You just want to make sure each of your pairs all together use all three equations. So I'll do 3x minus 2y plus z is equal to -5. I'm going to multiply the top row by 2. Okay, so this will be 6x plus 4y plus 2z is equal to -10. this goes away. I have 7x plus 7y is equal to 4. I multiply the top row by 4. So I have 16x minus 4y is equal to 4. 7x sorry, my apologies. Actually, we'll multiply by 7. Sorry, let me redo that all over. Yeah, so my apologies. Yeah, I multiplied by 7. I don't know why I said 4. So this will be 28x minus 7y is equal to 7. I'll combine them. And I'll have 35x is equal to 11. Okay, so sorry, I realized I made a mistake earlier. Okay, this is what I'm gonna do. Yeah. So yeah, I misread that. That should be minus as opposed to plus. So this should be 2 times minus 2y. So it'll be, yeah, minus 4y, and that will be positive y. Okay. So this is 7x minus y is equal to 4. So actually, yeah. So here, I'd actually multiply by negative 1. So this will be negative 4x plus y is equal to negative 1. So I have 3x is equal to 3. Yep, I'll divide both sides by 3, and I have x is equal to 1. Okay, so I always plug my first number into one of my 2 by 2 equations. So this is 7 times 1 minus y is equal to 4. 7 minus y is equal to 4. Negative y is equal to negative 3. Divide both sides by negative 1. I have y is equal to 3. And then I'm going to plug them both into the top equation. So I have x plus y minus z is equal to 6, which is y plus 3 minus z is equal to 6. 4 minus z is equal to 6. Subtract 4 on both sides. Negative z is equal to 2. Divide by negative 1. So I have z is equal to negative 2. Okay. So I have 1, comma 3, comma negative 2. Here's the thing, okay? As you can clearly see, okay, my apologies for messing up, okay? But as you can see, there is a lot of work, okay? And you will run into that, so as you can see, which is kind of good. I'm kind of showing you this, but it does happen, right? And these problems are really long, as you can see. kind of a tip for you guys is when you're doing these problems, it's just not gonna be kind of fun. You just have to kind of deal with it in the homework. Here's the thing on the test: if you're doing a problem and you mess up, okay, my suggestion for you is just keep going, okay. If you happen to have time at the end, you can double check, but I would rather have you just kind of work the whole thing out. If you mess up somewhere, just kind of keep piling through, um, and then if you happen to have time left over, then you can double check. Because here's the thing on the final, I don't want you to waste time just trying to like see like where you messed up, okay? Because it does happen for the following, okay? Just try to do the best you can. Just show your work as you kind of go along, okay? Let's do one more. Hopefully we don't mess up, okay? But yeah, we have something like this, okay? Where we have what's called an inconsistent problem, okay? So remember, you could have inconsistent. You can also have all real numbers, okay? So remember, inconsistent is when all your variables drop out. If you guys remember that, and the two numbers are not equal to each other, so that's inconsistent. And then all real, remember, or infinite set of solution is if all your variables drop out and you have two numbers set equal to each other. So the things that apply from section 8.1 also applies to 8.2, right? You either have one solution, infinite set, or no solution. Okay? So I'm just going to show you one last one, and then we'll call it a day. So if I look at number 7 here, I'm going to eliminate z as well. So let's do these two. So I'm going to multiply the top row by -1. So I have -3x plus 2y minus 2z equals -6. And I have 7x minus 3y plus 2z is equal to -1. So this is -y. This cancels. I have 4x minus y is equal to -7. Okay, so that's my first pair. So I have 7x minus 3y plus 2z is equal to -1. And I have 2x minus 3y plus 4z is equal to 0. We'll multiply the top row by -2. So -14x plus 6y minus 4z is equal to 2. Combine terms, so I have 3y and 12x. Okay, so I'm going to bring this other part down here. For the following. Oh, sorry, so this is negative. Yep. Caught myself. So, what happens sorry, I'm going to scroll down. Oh, there we go. Okay, so now watch what happens when I combine this, okay? So I have the -4x minus y is equal to -7. I'm going to multiply, plus 4x minus y equals -7. I'm going to multiply the bottom row by -3. Sorry, +3, not -3. So I have -12x plus 3y is equal to 2. And I have 12x minus 3y is equal to -21. So if you notice, my x's go away, but then also my y goes away. I'm left with -19. I have 0. Remember, right? You'll always ask yourself, is this a true or false statement? So if it's a true so this is a false statement, so we say no solution. okay? And that can happen, right? That means my planes never intersected with each other. If my two numbers are equal to each other as a true statement, then I'll say infinite set. Okay, so that's 8.2. As you can see, this is kind of an intense section. There's a lot of work, okay? But the concept, hopefully you guys should kind of understand. Do keep practicing. These are problems you can kind of mess up quite easily. But if you have questions, let me know. But other than that, we're done. Okay, so I'll see you guys, and we'll continue with 8.4. Yeah, there is no 8.3. We're gonna come back and we're gonna do 8.4.